Oh, okay, so into our fix stuff. So today we have this Victor automatic calculator, and this is actually a full four-function mechanical add listing machine. I believe it's based on the same principle as the smaller Victor 10 key and full keyboard machines, and then just added the automatic division and multiplication to that. So let's see if we can fix this. This machine does not work. I'll plug it in and see what happens here. So that's a bit sticky sometimes on the first key press. If you push the plus key, nothing happens. So you can open this up, and actually I wanted to mention the interface on this thing is kind of weird. There's the only control buttons it has are this one, minus, and this unlabeled button up here. I believe this is like division stop. This is like your regular plus, and then minus is of course for minus. But everything else is controlled by these three levers here. So this one is subtotal or total. So if you have nothing entered on the keyboard and you press the big button here, which I believe they usually call that the motor bar. So if you have nothing on the keyboard and you push this, it takes the functionality of this. So right now I hit the subtotal, or you can set it to total. This, I believe this is for repeat or non-add, where you flip it up or down. But that also seems to have some issues. This is the function control. So right now it's on plus or minus, so regular adding machine mode. You can also set this to, you can't right now because it's locked, but you can also set that to division or multiplication by changing this lever. So kind of a weird interface, but anyway, let's see if we can get this opened up. So there's screws in the two front corners, and I'll probably pause to take these out. It's not going to be very interesting, but there's screws in each of the two front corners and one in the middle of the back. So let me get this apart. Yeah, so I removed the screws, I removed the levers. Of course, we're missing one there, but this just comes off. Some of the sound dampening foam is coming loose, but anyway, so now you can kind of see the different options here, times, plus, minus, or division. They should have a sticker here, but I think that's fallen off. See if it's in the bottom of the machine somewhere. I have poked around with this a little bit before, and let me plug this back in. So like I said, the plus bar does nothing, but if you manually trip it, let me see if I can remember exactly how to do that when I was poking around with this last time. I believe it does at least try to do something, so see if I can remember exactly which piece to poke here. So last time when I played with this, either of these buttons would start the motor, and then if you trip the clutch or something, it would start working, but neither of these seem to do anything now. And looking over here on this side, this lever, even if these keys are all the way up, this lever is locked by, if you can see it right there, is a pin that's on a piece here that is inside a groove on this lever, and you can see it's locking it in place. Now I'm not sure whether this comes across on the camera, but it looks to me like that's bent like maybe someone tried to shove this up or something and bent that lever backwards since it was locking and they were trying to force it past. So I'm going to see if I can bend that back and see if that'll pop up out of there. Maybe it's just being held down by the fact that it's bent, and maybe it's not supposed to be down all the time, when nothing's engaged. So we'll see if that does anything to start with, since that's the first thing they can obviously see that's wrong. Well, I think the issue may have been in my power cord, actually. I went to unplug it to start playing around with that, and it did something. Not sure if you can see here, but it did print something right on the end of the paper. Let's try it again. This thing is kind of stiff too. So right now it's doing nothing. Alright, so yeah, this is what I kind of remember doing last time. When you push the key, it starts to go, but the clutch is not engaging properly. I don't remember exactly which clutch I was poking before that would get it to do something, but no, see, there's nothing wrong with this cord, and actually, if you look at the end of it, it was kind of chewed up, and that was kind of chewed up. So I might be looking for a different power cord. See if I can squash that one back into shape or something. But there seems to be one issue. If I can get this to. Something doesn't seem right with that. I'm hearing something else, either running or arcing or something. So that seems like a problem. Have to see what we can do about that. But the problem still remains that the clutch is not engaging. I'm not sure if it's this thing or. I'll have to look around that in a minute too, but I might try bending that lever back and see if that does anything also. So I manually tripped the clutch myself, and that is, let's unplug this, that is this piece. It's going to be hard to see. Let me flip this around to get a better view. Is this piece right here, which you still can't see. So if I pull this up, which I may not be able to do, let me enter something. If I pull this, I'm not sure if that did anything or not. If we plug this in here. Okay, so yeah, seems like that's sticky, so it doesn't want to trip, and then once you do trip it, it keeps running until I disconnected the power, and I guess that gives it enough time to reset itself. So that's going to be a problem. You can see it kind of entered a number. Try that again. I did 1. But maybe this thing didn't advance properly. And if I push this and trip the clutch, I think that tripped or not tripped. Let's see if that'll run now. When it is connected, then it resets. I wonder why it's not printing the first number I enter. Let's try 7, 8, 9. I don't think this is one of the later machines that has the stupid deteriorating pegboard, but could be. Yeah, so now it's not printing the first digit. So I'll have to take a look into that too. I have a problem with that. So I think I'm still gonna rebend this lever back and see if that affects anything, and then I'll take a look into how this is supposed to be connected to the clutch back here, and I'll also take a look into why it's not doing the first digit, because if the pegboard has a problem, that's a whole nother thing to deal with. Alright, so making some progress here. So this key, the stem that runs down has a spring attached to it, which is attached to the end of a rotating shaft, which runs all the way across the machine and is then attached to a basically the other end of the pivot arm for the dog clutch release in the back here. However, there's a catch that is locking that shaft from rotating, so that's why when you push the key, the motor runs because that's controlled by another part of the key stem, but the clutch doesn't engage because it's locked. So if I hold the lock, let's enter something first. If I hold the lock back here and then push the key, see it prints. Of course, it's missing a digit there, we'll have to figure that out. Although if I enter 4 digits, you see then it prints the first one. So something is funny in that second column. I don't think it's a pegboard issue, because I looked up in the bottom and I don't see that pin dropping down. And if it was a pegboard issue and the 0 pin was dropping down inappropriately, then it wouldn't print in that column either. So something must be sticky with that third column not wanting to rise, unless something's been under left of it. So I'll have to figure that out. And I also have to figure out why this catch is engaged back here. So just for fun, let's see if we can do a total. So I'll push that down, and now what happens if I do this? No, so total doesn't seem to be working either. If I do a subtotal, I'm sure it'll be the same thing. Yeah, so total and subtotal don't want to work. I don't even know if it's adding or not either. It's just printing. Of course, I don't know what this lever does either. I haven't found the sticker for that, I don't think yet, so I'm still looking at it. There's supposed to be a sticker there to indicate what that does. Not sure what happened to it. So yeah, some progress, but not that much. There's still a lot to figure out on this machine. I wonder what minus does if I put. Yeah, so he doesn't even print like a minus sign or anything, so yeah, I'm expecting that most of the problem is going to be just dried up grease. Over here on this side, I bent that bent piece back, and I took this off and this piece off to get access to it, and both of them were pretty caked in dried grease. This is a lot freer now since I cleaned it up, but the piece that was bent, the lock for this, is still pretty sticky, and there's a release that is supposed to hold that out when the machine is not, running a complicated operation, and that piece is also very sticky, and that's why I think that was engaged, because there's this spring here is attached to this piece, which actually releases this piece, so that when you're just when the machine's not doing anything, you have the freedom to change the mode, but then when the machine does something, then it would lock that in, so you can't change it in the middle. And there's a shaft with cams on it down here. It might be kind of hard to see. You can just see these two plates right here, and then you can maybe see, I don't know, but these two plates right here, the end of the shaft with the cams on it, and there's a finger that runs from that lever down to that camshaft. So when that camshaft rotates to a high point, then it would push that lever backwards, which would release this lock to lock in and lock the mode from changing. Yeah, both of those levers, both the one with the pin on here to lock and the lock release, are pretty sticky with dried grease. So I think that's going to be the main issue with this machine. Is just going to be a lot of dried grease sticking things. I dropped one of my C-clips on, and then I turned the base, like I turned the machine up to get it out, and this rolled out, so I had no idea where that came from, or what it does, or if it's important, so that's going to be fun. So yeah, next thing I'm going to do is figure out why the lock is engaged and locking that clutch from releasing, and then I'll probably move on to see, if we can get it to total or subtotal and see if it actually is adding or not. Alright, so I'm making some progress here. Bring this to stay out of the way. I did kind of get total and subtotal working. As you can see, it's putting T's there for total. There's still a bunch of sticky stuff yet, and it doesn't add properly. So, like for example, I entered 4 times here, but it's still only summed up to 15. So something's definitely wrong with that. But you enter, say, something like 5. I only entered 1 because it's still sticky. Let's try 5 again. The time I entered 5. So let's see what our total is now. 6. So that time it added properly. But like you saw, that first time I entered 5, it only put a 1. So stuff's still sticky. Let's try 25 plus, let's say, 45. That time registered properly. So that would be, 70? So let's do a total. 35, yeah, so even the total doesn't always, it didn't add properly. It only registered 45 in the register, and then when it totaled, it didn't total out the full amount initially. So it totaled out 35, but then it still had 10 left in the register for the next time. So stuff's definitely still sticky, but I'm making some progress. Let's try 55. So I registered 15 that time. Did it register the whole number? Yeah, didn't even add it in. So definitely something's wrong here. Let's enter some random garbage first. And now let's try entering 25. Now let's try entering 5. Now let's see what the total is. 20. So yeah, definitely issues there yet, but seems like total is at least trying to work now. So what I did to get to this point was basically the mechanism over here. All of this stuff was all kind of, at least you can say I cleaned up this piece, cleaned up this piece. This is locked in. I'm not quite sure why. But basically, all the levers that were part of this locking mechanism for this, I cleaned up because I don't think it should be locked now. And I noticed that they were pretty sticky, so I cleaned them all up. And in the process of doing that, I had locked the timing cam in the bottom. It seems like this is pretty similar to the deal machines, where that shaft with all the cams on it is not positively timed to any other part of the machine. It just has like a ratchet that advances it through its different possible, states. So, who knows? Maybe that was out of time or something, and wiggling it when I was trying to fight with the levers, put it back in time, or maybe it was just sticky. Maybe it wasn't, in a detent, and then now that I loosened up the detent lever, which was also part of the mechanism, maybe now the cam is actually stopped in an appropriate position and not, somewhere in between. But either way, there's still something funny here though, because this should be released and it's not. Like this piece should be forward like that, so it can be released. So it'll go into multiplication mode that way, but it won't go into division mode. But that way it'll go into multiplication mode, it won't go into division mode, but there's still something funny because this should be released at this point, and it keeps trying to spring back into not released mode. So I still have to figure something out there, but it seems like cleaning that up and possibly, maybe moving the cam a little bit, seems to have brought back the total functionality, even though the math is nowhere near correct. So probably what's causing this is stickiness either in the register itself or in these risers, because there's nothing positive actually driving these risers. Everything's under spring tension. So if the riser is sticky, which you can see the bottoms of them right here, if these are sticky and they don't want to slide back, again, under the spring tension, then it's not going to register the appropriate number on the keyboard, and it's also not going to read the appropriate number out of the register. And same thing if the register wheels are sticky. I'm not sure whether this machine adds on the forward stroke or the backstroke, but if it adds on the backstroke, it would always add whatever these slid up to. But if it adds on the forward stroke, if the register wheels are sticky, then again, these won't slide up under spring tension to register the appropriate number. So I'm going to have to see if I can figure out what's sticking here, or maybe just soak a bunch of oil on all the parts of these I can see and see if that starts to loosen things up. But either way, we are making progress. Let's try something like, so if we do 1, 2, 3, it won't register the first number. There's something funny there. What happened if we did 0, 1, 2, 3? Same thing. But if we do 1, 1, 2, 3, then it'll register it. So something sticky with that, like 1, 4, 5, 6. 1, 1, 5, 6, 1, 7, 8, 9. Same thing. So let's see, what if I do like 7, 7, 7? What if we do 7, 7, 7, 7? So that's gonna, so there must be something up with the riser in this position wanting to stick to the one next to it, that they always enter the same number. So if we do, say, 8, 8, 8, 9. Oh, it didn't work. 8, 8, 8, 9. So now they registered both 8. So what if we do a total now? Yeah, see, it doesn't always want to clear that out. If we enter all 8s, oh, we need 1, 1, 8, 8. What do we get for a total? So registered the total pointed out properly that time. Try that again. It's going to be difficult now. So that added properly. 15 plus 1 is 16, but it should have added 25 plus 5. So I have to figure out. Alright, but anyway, like I said, progress, but still way more to do on this machine. We have a problem. So I took the keyboard out so I could get this piece free to slide all the way over, which again you can do by entering all 9s, but I wanted to get this to slide all the way over and also get more visual access to the risers here, so I can try and see what's sticking them and sticking to them together. Like the third and the fourth one always rise to the same number. But now that this is all the way over, so you can see that here it has a plate that is what pushes these pegs up so that when you return it, it clears the pegboard. Actually, just do it like that. So like that's the starting position there. I guess maybe right about there is a starting position. So that we line up, and then as you push a pin, it pushes, each thing down, one pin in each column, depending on which key you press. And then this plate here pushes all the pins back up as it clears to reset it. So now with this all the way over, there's empty space beneath these pins, and that's where the risers come up to hit against one of the pins. But if I tap this here, You can kind of see that one drop down. Maybe you can't really see. Let me tap it up here. So I'm not sure if you can see, but almost this whole column dropped down. Just these ones at the bottom are still up. This one dropped down, that one dropped down. Some of these started to drop down. One over there dropped down. Two there. Those top two. If I tap it some more. So, what does this mean? This means that this has the crappy plastic detent springs for these pins that basically deteriorate over time, and then the pins lose their detent. And on some cases, it gets so bad that as soon as you slide the pegboard out, the pins start falling down. This one doesn't seem as bad, but it's only going to get worse as time goes on. And when the machine is multiplying or dividing and it's running through multiple cycles, that's going to be kind of similar to the vibration. It's maybe not as excessive, but still going to be a good amount of vibration operating on that, which may cause some pins to drop down when they shouldn't. So this is going to have to come out, see if we can do something about that. But while that's out, that'll give me even better access to these risers, so I can hopefully see which ones are stuck. So not really surprising. That's a common issue among victim machines. They went to that stupid plastic spring detent thing, and basically they all fail. I don't know why they didn't just stick with metal springs for the detent, but whatever. So this is going to have to get pried apart. You can see it's staked in multiple places. It's kind of gross on this side anyway. So yeah, that's a problem, and I think I can fix it. I've experimented before with a more basic machine than this, tearing this apart and pulling out all those deteriorated plastic pieces and replacing them with foam. I actually have a piece right here. This kind of, I guess, polyurethane or something, foam. So we'll try that here, and hopefully that will future-proof that issue. Now again, that foam can go bad eventually, but I guess 50-year service interval is better than not working at all. So to take this out, you have to take this rod out, and it has a C-clip. There's a C-clip on this side, C-clip over here. I can just pop out of here, maybe. Maybe not. I have to probably fight with that a little bit, but so that comes out. And then this shaft should slide over. Got something to poke that with. Getting in the way here. So this should slide over. I'm hitting something over here. There's another C-clip right down in there, which I can't really get at right now. So I was hoping it would slide out somewhere in this direction so I could get to that, but may not be the case. So let me fight with that for a little bit and see if I can get that out of there. Alright, so I've pried the top off the pegboard box here. I think when I bent it a little bit, prying it off, I'll just bend it back. It's not too bad. And you can see what has become of our detents. So there's pieces of them stuck to there. And there's hardly anything left in the first column. They all just kind of crumbled down to the bottom. Let's take the rest of these out here. And see if we can, how if we try to lift this up. See, and that's about what's left of it. Focusing on that. Focus. There's just about one solid one left in that first column there. And let's take out the pins in the next column. The pin's stuck for some reason. So where's that one? Oh, this one. It's also stuck. Oh, there it goes. Just felt the crumb fall at the bottom of my hand. Oh, that one just fell on the floor and shattered. Oh, so you get the idea of what happens to these. So all these are going to come out. I'll take all the pins out, clean up all the crumbs in the bottom there, and we will make new strips of foam out of that foam block that I showed, and we'll stuff those in here, and that should be, you know, the foam will last much longer than these will anyway. Definitely a much better solution than what Victor used. Like I said, the foam will eventually fail, as these have, because it is just polyurethane plastic. I'm not sure if there's some kind of foam that will last infinitely, or, you know, the best thing to do would be to try and build some kind of cage for metal springs and put, you know, the old style metal springs in here, but not quite sure if I want to get into that. So we'll just use the foam. It'll allow this machine to continue to function at least for another 50 years before the foam fails, and we'll continue fixing it. I was able to unstick these stuck risers here, so you can see with the pegboard assembly out, we have a full axis view to the risers. This is the pegboard return spring. These are the risers right here, or part of them, and they continue up, and then you can see the tooth sections up there. And these are the springs that pull them back. So basically what I did was, with the pegboard out and with this piece, this is the kind of like a position sensor and also actually the return. So when this is like this, the machine knows that the pegboard is in the home position and it does the total or subtotal. When this is out some other way, then it allows these to rise up to read off the pegboard. So if you leave this out without the pegboard in, it just enter all nines. You can see, well, you could see if I showed it, this enters all nines like that. So I left it like that, I put it in repeat mode, and then I let it run, and then I pulled the cord when it was in the middle of an operation so that these had all risen up. And then basically what I did was I used one screwdriver to kind of push them back against the spring tension, and then another screwdriver to kind of pry them a little bit, and they all popped free. So not exactly sure what was stuck. I'm not exactly sure where the register is in this thing either. There's two registers down here, but those don't seem to be active for regular adding and subtracting, so those might be multiplication and division. There are another two registers underneath, which you can't really see because I don't think you can operate the machine with it upside down, although I haven't tried. But they're all the way right on the bottom underneath the back section here. There's two more registers, so you know whether the two of those wheels got stuck together, which is kind of what I'm leaning towards, given that there's pretty good separation between the risers here at least. I don't see anything up here, any place up here where they could get stuck together. And I'm kind of leaning towards that maybe two of the register wheels got stuck together or something. So we can't really test this to see if it's going to add correctly until I fix the pegboard. So I'm going to do that, and then I'll put it back in, and then I'll put the keyboard back on, which this actually comes off fairly easily. There's two screws in the front here, and then these two pieces up on the side, which go into grooves on the frame here and here, have these pieces which kind of slot over like that, and then there's a screw that goes in to hold them in place. So basically just 4 screws to take that out, and it basically comes right out. The pegboard, as I showed, has this pin that goes through the shaft. I took, I think, 3 or 4 C-clips off of it. There was one here, and I think there were another 2 here, and then maybe one somewhere else. Maybe just 3. And that slid out that way. So yeah, and I'm taking this cheek clip off. I was going to try and take this off, but I would have to take this piece off, which is adjusted here, and I'm not sure what happens if you get that adjustment wrong. So since I don't really have to take this out, I'm just going to leave it in and see if I can clean this up a little bit though. Doesn't seem that bad. So I'm not exactly sure what happened with this machine. You can see that, especially right here, there's a giant pool of some kind of white grease. And also, if you look at the inside of the frame here, there's white grease kind of splattered all over the place in here. And the same thing like kind of like down in here, and then a little bit also like over here. You can see there's kind of like white grease just running all over the place. So I don't think that's original. Like a lot of these older machines use some kind of like brownish grease, and you can see evidence of that here too. Like right there in that corner, you can see some of the brown type grease. And there's numerous places, other places on the machine where there's that brown grease as well. So I don't know where this white grease came from and why it's like splattered everywhere. I don't know if someone just got this machine and thought they could spray some grease on it and have it work, and when that didn't work they gave up, or what. I don't really know. But it's kind of unfortunate in some places because you can see here, right here, they just kind of sprayed it right over top of the dirt, so now there's greasy dirt all over the place. Including like down in here where you can't really get to clean. So I want to see if I can flush that out with brake cleaner, something to, or some kind of solvent to wash the dirt grease mixture out of there. Yeah, I really don't know where that came from. It's kind of weird. So anyway, first step is to rebuild this pegboard and see where we can go from there. So you can see I'm working on putting some of the foam in there. You can see all of these pins is just, you know, it's the same diameter on both ends, and then has a kind of like detented section in the middle where the little fingers there, you can see the fingers on the detents would go into the little divots there on that piece. This is the only intact one I pulled out of there. This one's pretty close, but you see the bottom corner there, it's broken off. The corner pieces right here. And it's further falling apart as I poke it. So got 2 more rows of foam to install, and you can see these ones on the end are basically the same, except they have this extra extra piece that sticks off of the back on the top. But the front of them is the same, and the bottom that sticks out the bottom of the pegboard sticks out down there is the same. So I got to stuff another row of foam in here, and then another row in between those two. And then comes the fun part of getting all the pins lined up with the hole in the top cover. So I did put a piece of foam here that doesn't actually, that's not for any like, you know, functional part of the machine. It's just to keep this piece somewhat lined up, because with the foam pusher here, this piece is going to be pushed way over, and it needs to line up with the top hole and the bottom hole on this column. So that's just there to kind of keep this somewhat upright, so it hopefully won't be too hard to get those end pieces, end pins there lined up with the holes in the top plate. So I'm going to put those 2 rows of pins back in and see if I can put this back together. Alright, so I got the refoamed pegboard back installed, put the keyboard back on, just held in by 1 screw here and that tab, lock tab in the corner with the 1 screw in it. And let's just see what happens now. Do 1, 2, 3. Hey, it actually works. 1, 2, 3. So, yeah, freeing up those stuck ones seems to have fixed our non-print in that column. Let's see if we do a total. It's at 0, so we didn't actually add anything for some reason. That's lovely. Let's try it again. So now it did 246 for the total. Okay. Oh, it must not have. Okay. It was just doing 0. It didn't do a total, that's why. So actually it did add it, and then it added again, and then it did a total. So now we are printing a total. Let's try 1, 2, 3. I will do a total. There it did. Okay, so that part works. Let's try 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 8, 7, 5, 4, 3, 1, and it added nothing. Perfect. So something's still messed up there. It added up here though. I don't know why it didn't add. That's interesting. It did 5, 7, 9, so it added those. I got 0. So 2, 5, 8 is that correct? I don't know. No, it should have carried over here. So missing a carry in that column. That's interesting. How happens if I do, let's see, we got 0, right? So 999 plus 1 total. Okay, carry is not working. So it added 1 to 9, but didn't carry over to the next column. So I have to figure out what's up with that. In the meantime, what happens if we do, say, 25 and minus 4? It added instead of subtracting. So subtracting doesn't work, carries don't work, but at least now we should be able to enter independently in every column. Get that right. 1, 2, 3, 4, 5. I think that's a 6, 7, 8, 9. So yeah, all the columns are now independent. I did print a 0 first. I'm not sure what's up with that. I didn't enter a 0. Anyway. And it does total out in every column correctly. So looks like our issue with the sticking columns is resolved. However, we now discovered an issue with subtraction not working. Just doing addition, so maybe there's some switch lever somewhere that's stuck, not turning it into subtraction mode. And it seems like none of the carries work, which is interesting. So let's see, if I enter a bunch of 9s again, and we'll try entering, let's try entering 10. Does it carry from that column? Let's do subtotal. Why did I get an 8 here now? That's interesting, but it did not carry over, so it says 9908. I don't know where this 8 came from. What if I enter 100? Oh, it must have just been something sticky there. It just didn't register all the way up to 9. Now it registered 9. So yeah, none of the carries are working. Add 1 to 9 in any column. It doesn't carry over. So that's lovely. Yeah, that was too many, I think. Yeah. So yeah, none of the carries seem to work, so we're going to have to figure that out. Yeah, none of the carries work. Change this back to total, clear that. Okay, so again, some progress, but it's moving along very slowly here. Seems like there's many issues with this machine, and just have to peck away one of them at a time. So, what have we accomplished so far? So, we accomplished some gummed up levers on this side, or maybe incorrect timing of the camshaft was causing total not to work. Some of the risers, or my suspicion is some of the wheels on the totaling register were stuck together, causing certain columns to always enter the same number. We resolved that, it looks like. So we were able to enter, it's not printing so well, but we were able to enter 1 up through 9 independently. No two columns entered the same value, so that seems to be resolved. We preempted an issue with the keyboard pegs. Like I said, we hadn't noticed yet that any of them were falling down during operation, but that issue would happen eventually. Maybe you would have noticed it during multiplication, where I'm assuming it's going to use the pegboard to store the entry for the entire multiplication operation. So it might have cropped up during that. But we've preempted that. So hopefully that won't be an issue. And now we've got to move on to carries, and then why subtraction isn't working. And then we have to see if we can get multiplication and division to work. So this is going to be a fun one. That did something. That did a total. Okay. Anyway. So yeah, making slow progress here. Hopefully we can get this thing working. So next I'll look into the carry issue. Alright, so making some progress here. As you can see, I was just able to successfully add all these numbers and get the correct result. Go into what I did in a minute. It's still not 100% right yet, but we should be able to do 1, 2, 3. Now I'll have to enter a 0 to do a total. Well, it almost got it right. So we still missed one carry there. 2, 3, 3, 0. That should be a 3. And try it again. Alright, sometimes it does that too. Oops. Well. This is the one. So sometimes it also doesn't always clear out the total register properly. You'll see it printed out this number, but then there was still some garbage left in there. So, like I said, still not 100% right, but we are making progress. At least it does carry now. Before it didn't carry at all. No matter what you did, you would never get a carry from one column to the next. Let's see, what do we have in the total register at this moment? It's claiming 0, so let's try it again. Enter 0. And total. There, now it worked correctly. 3330. That is correct, and it cleared out. So, like I said, still some issues. I don't think, minus doesn't work yet. I didn't play with that. And the reason you have to enter a 0, I'm not really sure what's wrong why you have to enter. I don't think you should have to enter a 0. If you don't do that, then it's more likely to get some garbage stuck in the total register. So, maybe that act of entering a 0 somehow, give us some sticky part time to reset before totaling. I really don't know. I'm gonna have to figure that out. Let's try it again. Oops. So you still garbage stuck in the total register. So this is kind of just a game of playing with the machine, seeing what will start loosening up and working on its own, and what you're going to have to dig down inside to manually free up. And the carries were one of those. Playing with the machine didn't seem to have any effect whatsoever on like none of them started to come back at all. So let's flip this over. Unplug it here. I've got some wooden props to prop this up. If we can flip it over. I'm kind of just resting it on the pattern. Make sure I've got it. Sit on there. good. So the issue with the carries was, so these seem to be the same register. It looks like the gears are meshing on these, and they're part of the same frame, so I don't see any way that one could be driven without the other. Why they have two, I really don't know what the point is there. But when I first looked at it, I thought that they would be independent. Like one would be, you know, a counter, and one would be a total, or one would be like a memory or something. But it looks like they're conjoined, so not quite sure why. Anyway, these fingers here are the carry trips. So these register wheels under here, which I'm not really sure how well you can see, but see the teeth poking out there? These are the locks to prevent them from free floating when they're not being driven. So those gears there each have a little finger on them that sticks out, and when that finger rotates past the end of this lever here, that trips the carry. And in most machines, they also have the effect that when the wheels rotate backwards to total, that finger also stops against either this or something else to stop the wheel at 0. I'm not sure if that is how it works in this machine, because I really can't see in there at all. Those fingers trip these levers to enact a carry. So when like the wheel on this column trips this finger, it will allow the next wheel to advance one position. And basically what it does is, let's set this down here, is in between each of these levers is a rocking portion that's driven by the risers as they rise up to record the number. So those rocking portions have teeth on them that drive these wheels. So basically, as the risers rise up, they rotate the rocking section with the teeth on them, and the teeth in turn drive these register wheels for the appropriate number of positions. Now, to affect the carry, basically what it does is it allows the rocking portion in the next column to go, when it returns home, it allows it to go past its normal home stop, basically turning the wheel in the next position one digit more than it would have. So when these trip, they release a latch that, or I guess I should start with, when the risers return to their home position, these rockers also rock back to their home position until they're stopped by a tab on each of these carry trips. When the carry trips, that tab basically moves out of the way and allows that rocker to rock an additional position pulled by spring tension, and that additional movement of the rocker drives the register wheel one additional position forward. Now, right now, all of these carry trips are, if I trip them, they're going to stay tripped, because when the rocking portion springs back with that additional movement, it basically traps the carry trip from returning to its home position, which of course it will be reset during the next machine cycle when these all, rock backwards. And that's why most machines require an empty crank before totaling to reset all of the rockers and carry trips. Usually victim machines don't, and I think this one shouldn't either, but basically my entering 0 is kind of affecting that same idea. So what the issue was, like I said, right now these are, if I trip one, they're going to stay tripped because the rocker springs forward and locks it. However, when the rockers are out, like say I had, 9 in one column and I'm adding another 9 to that. So the carry is going to happen when these rockers are basically all the way out. Like these rockers are going to rock all the way back because I'm entering a 9, and then as soon as they start to rotate forward again, the first position, it turns the register wheel, so the first full tooth of the rocker that moves is going to cause the carry to happen, and then the rocker is going to continue moving past, back to its home position after the carry has been effected. So when that happens, they need another latch to keep the carry trips tripped until the rockers return to their home position and effectively lock them in the tripped state. And what does that is, I'm not sure where you're going to be able to see this, but right down under here are little spring-loaded. Let me trip one of these to be easier to see. So if I trip that one, see now it stays tripped. I'm not sure if you'll be able to tell, but this rocker here has advanced one position back. So see how there's a tooth here, and then this tooth is further forward, and then the rest of these teeth. So that has effectively manufactured a carry in that column. Or it would have if the register had been engaged. Right now it's disengaged because the machine has completed its cycle. But normally those would happen while the register is still disengaged or still engaged and drive it forward that additional position. Anyway, so right down here is a little spring-loaded catch. I'm not really sure if you can see it. I'm just pushing it with the fork and it's kind of, with the pick, and it's kind of springing back. Still a little bit sticky, but basically all of those and all the columns were really sticky, and that's what the issue with the carries was. So whenever you'd affect whenever one of these carry arms would trip, basically it would just spring back to its non-tripped state because nothing was keeping it there. And then when the machine reached home, no carries would be affected because by the time all these rockers got back to the home position, any of these carry chips that had been tripped had already sprung back to their home position, which is effectively the no carry state. So I would really like to take all of this out. I really don't see a way to do that. These pieces here make up an assembly that rocks up and down to lower and raise the register in and out of engagement with these rockers here. And those have pins that rotate in these side frames here, and those side frames seem to be pretty well trapped by this plate. So as far as I can tell, without basically disassembling the entire machine, I don't think this is going to come out of here. So what I did was I squirted some oil down in there and then kind of worked these for a while. Like I said, some of them are still kind of sticky, but some of them work well enough that we were able to successfully add and get an appropriate result sometimes. So I think this is now going to be a game of just working these and running the machine until they all are going to work properly. And I'm not sure if those are related to the issues I'm having with totaling or not. Right now I don't see a way that they could be, but maybe just something that I'm not noticing. But so I'm going to see if I can get all of these working reliably each time, and if my totaling issue hasn't resolved by doing that, then I'll have to look into that next. But at least that's something now. So now we can at least use this machine 50% of the time as an adding machine. So like I said before, it's slow going with this one. Definitely a lot of problems in here, but well, at least we're making some progress. So that was the issue with the carries. Like I said, it's not completely solved yet. I'll see if I can. I'm going to have to see if I can make those reliable, and then move on to the next thing. So in the last section, we got addition pretty much working, except for the still intermittently sticky carries. So I decided to try multiplication just to see what would happen. And unsurprisingly, the machine just went into some random state where it kept putting garbage the entire time. So I've been taking a look at the multiplication mechanism, and I've already partially disassembled some stuck pieces. But so the obviously machine is flipped over, and this is the front. And if you remember before, we had two registers up here. I've taken one of them out to clean it, and I'll show that in a minute. But pretty much everything to do with the multiplication registers in the front here is pretty sticky. So it took me a while to figure out what exactly is supposed to happen. And it turns out that the registers actually move. So this piece here slides, and you can see as I do that, the whole register slides with it. Now, initially that was completely frozen, and this wouldn't move at all, but I managed to get it loose and oil it, and now it slides and springs back. So that's probably part of the problem with multiplication. Probably what it has to do is slide this over. It's going to check each column for a number and then count that down to 0 and then move on to the next column and so on. So that's freed up now. There's also a mechanism to engage and disengage the register, so that's this. So if I move this bar here, which is controlled by some levers over here, so little pin that goes in, then they can grab it and pull it back. That drops the register down, or in the case when the machine's already set up, it would actually push the register up into engagement with the teeth on the bottom of the risers here. That's your engagement and disengagement to either add into or read out from that register. Now, the second register in the front here that I've taken out, I believe is the counter register. And if we take a look at it over here, the reason I've taken it out, let me get this in closer here. The reason I've taken it out is because it's completely seized. So you can see how these gears here are all stuck together, and compounding that, these little spring detents here are also fairly sticky. They're somewhat better now, but when I had first taken this out, most of these were actually glued in place, and then when I wiggled them, they started springing back against spring tension. You can see how sticky they are there. So these being stuck in combination with the register wheels sticking together, which now they're starting to pop apart a little bit, meant that I could not turn any of these wheels at all when they were in the machine. So it looks like we've got these detents here. I have to clean those up. I have to obviously clean all these up. I believe these are like 0 detections, so when the wheels get to 0, these will either extend or retract or something for it to determine that the wheel is at 0 and probably register that and move on to the next digit or something like I was explaining earlier. They're kind of sticky too, so I'll have to clean those up as well. So it kind of sticks there. So those have to get cleaned up. This is the shaft that the register rides on, so that goes in there. And then there's 2 clips that go on here and here, hold on to the shaft, and then this shaft slides with that assembly. So both registers slide together. This is part of the counter. This is why I think this is the counter register. So you see we got this square section here, and then on that there were these pieces, and then in between those pieces were these little square tabular things like this. Just put them on there. And then there was another one here. And then these are held by, this was this shaft, and I think this also slides. I'll fade that one and put it all back together. But these look like they can slide back and forth on this square section here, and then as this shaft rotates, I believe these little fingers here, well, I just pulled it apart, but that's fine. Put it back together. Those little fingers there will engage with the teeth on the register, either increment or decrement the particular column they're in, depending on which direction this turns. It might only turn one way. And then you can see it's got this funny piece on the end here that is actuated by this little finger here. So as this goes up and down, when it comes down, this little finger pushes on one of these little nubs here and rotates the shaft. So it's going to push it every time it comes down, and then this springs back for the return trip. So it's going to plunger it every time this comes down. It rotates this shaft one position, which in turn will rotate these fingers one position and decrement or increment, probably decrement the counter register one position in the position that these sliding fingers have slid to. So I'm going to clean all of these up, make sure everything is nice and smooth in here, and then figure out how this all goes back together, and then we'll see what multiplication does next time. And I don't think that's going to solve the issue because I think there's still some other issues with multiplication, but you can see here, this is the main timing camshaft that runs all the way through the machine. And right here, I'm not sure if I showed this before or not, but right here is the actuation mechanism. So you can see these little fingers that come off the shaft. Well, up underneath there's a finger that comes down and punches the flat faces there to rotate this camshaft around. Now, as far as I can tell, that actuation finger will only rotate this camshaft when there's something entered on the keyboard. So if the keyboard is empty, and I'll see if I can show this when I flip the machine back over. When the keyboard is empty, there's a finger that lifts that actuation finger up out of the way, so that if nothing's entered on the keyboard, this shaft shouldn't rotate. Another problem that I'm having is it's clearing the keyboard for some reason when I try to start a multiplication, and then when that happens, this camshaft gets stuck in the multiplication state, and as far as I can tell, there's nothing to actuate it to get it to return back to the finished or the regular add subtract state. So that also has to get figured out. But first what I'm going to do is put the register assembly here back together and just see if we kind of figure out what exactly is supposed to actuate that and kind of how that's supposed to work, and then see if it actually is working like it's supposed to. Alright, so I just got a semi-successful multiplication, sort of. You can see I tried to do 5 times 5, it ended up to 4 for some reason, so I'll have to look into that. But it did do 4 times 5, put in a bunch of zeros, and then it came out with 20, which is correct. So let's see if this is figured out. I can try it again, go into multiplication mode, try 5, entered 5 that time, 5. Prints out a bunch of zeros for some reason. If we go back into regular mode and do a total, hey, it's right. So I don't know what the deal is with a bunch of zeros being printed there. I'll have to figure that out. But definitely progress. I'm pretty happy to see that actually getting correct answers for multiplication, in 2 digits anyway. Let's try, 2-digit answer rather, 1-digit input, 2-digit answer. Let's try 2-digit input. 25. Actually, yeah, I have to switch into multiplication mode first. I'll do 25. And let's try 25 just for fun. And go back into regular mode, do a total. Hey, that's right too. Alright, so that's kind of surprising. I spent a lot of time fighting with this. Let me flip this over and see if I can give a bit of an overview on how this works. And I realized I was incorrect. It does actually clear the keyboard, I believe, for multiplication. I wasn't actually watching this time, but I believe it does because it has 2 registers down there, and I think it stores the one factor in one and then the other factor in the other. And instead of using the keyboard as a register, I believe it uses the register down here in the bottom as in place of the keyboard register as a factor storage while it counts in the other register. So I was incorrect about it needing a input on the keyboard to advance the timing mechanism. So if we look all the way down in the side here, so I can point this out. See these 2 levers here, the 2 pins right there? So on this pin right here, notice there's a lever that comes from the bottom up over top of that pin and then kind of down in the front again. That lever is the one that advances the, it's kind of like a ratchet type thing on the timing camshaft. So every cycle that comes forward and back, and if it's allowed to engage with the timing camshaft, there's a nip on the end of it that hits against one of those flat pieces and rotates the timing camshaft. So normally that's held up by 2 levers. One is this pin right here. You can see that holds it up. And if I enter something on the keyboard, notice how it drops down. So that's one piece of the puzzle that drops down to engage that. And then I'm not sure if you can see, but there's another pin. Right there is another pin that runs across. And that other pin is controlled by the mechanism here. So if I shift this into multiplication mode, you'll see that pin drops. And if I enter something on the keyboard, that drops, and then those two things dropping will allow that ratchet movement, whatever you want to call it, lever there, to drop down and engage with the ratchet on the timing camshaft and advance it. So I thought that in order for the ratchet mechanism to ever advance, the timing to ever advance and ever change state, you'd have to have something entered on the keyboard in order to release that to drop down and engage. However, upon further inspection of that camshaft, I realized that some of the ratchets are taller than others. So I believe that, like right now, it would have a short ratchet engaged, or a short ratchet there in line with the actuation mechanism there, so that when you're doing regular, adding, totaling, it won't advance because it's being held up. Now, as soon as you put it into multiplication mode and have something on the keyboard and run it, then it drops down and advances the timing by one step. However, once it's in multiplication mode and the keyboard is clear, now, in order to advance the timing, it's being held up, but I believe at that time it's lined up with the taller pieces on that camshaft, so that it doesn't need to drop down to engage them. It can always engage them. But there's still some unanswered questions there, because it has to remain in some state until it finishes the multiplication and then advance to the next state. So I'm still not exactly sure what causes that, but I think my assumption that you have to have something entered on the keyboard in order to ever advance the timing was incorrect. It looks like it does not use the keyboard for the multiplication sort. It actually uses the storage register down here. So, let me flip this over. Okay, so these are the two multiplication registers here. Now you can kind of see the gear teeth of one in there, and then the other one is down under there. I think I showed it when I had this one out for cleaning. The way that this works is, I believe when you enter a number for multiplication, it'll sort either in this register or this register. And these registers can drop. I'm not sure if I can, see that register can drop to engage with the risers, and this one can also drop to engage with the risers. So it can enter a number into either one of them. This one is the counter. Like I described before, it has the little tooth section down there that's run by this, and each time this rotates, it will adjust the position of them by one, and this whole thing can slide over. Let's see, can we slide it over right now into at least this? Ooh, let's get that one a little bit more stable there. Yeah, so this whole thing slides over. And it's driven by this, so at the right time, this pin here drops down to engage with the lever down there. So this drops down, and then this whole thing rotates, and when that happens, that pin pushes on this lever, which runs all the way down to here, and in turn pulls the assembly across until it stops. And it's timed by this. This can either be up or down, and that will release this thing to slide. And there's a little cam there that it rides on, so that'll lock or unlock it. Now, what controls where this stops? So, I'm not sure if you're going to be able to see, but right down there, there's a little pin on this stamped piece. I'm not sure if you can see it, but when a number is entered into the back register here, you can see that it has these pegs out here, and this one's folded in. So it's allowed to, these are controlled by basically they determine whether a number is entered in there or not. So right now all of these are at 0. I'm not sure why that one's not. I'll have to look into that. But all these ones are at 0, and when they're at 0, there's a little tooth on them, kind of like, like your regular tens carry tooth, basically. There's a tooth, an extra little tab kind of thing at the 0 position that engages with these pieces and pushes them backwards in this case, so that they all stick out the back. And because they're all sticking out the back, there's nothing sticking out the front, and because there's nothing sticking out the front, they're allowed to slide past that sand piece down there. You can kind of see it. So basically that determines kind of how large the entered number is, basically. So it will allow this thing to slide over until one of the tabs sticking out the front hits on that sand metal piece, and basically that aligns the number to the leftmost position. So let me try and explain that a little bit better. Basically, these little tabs here determine whether a digit is entered or not entered in the column. Right now, all of these ones are showing no digit entered, meaning there's a 0 in the position in the register. I'm not sure about that one, that might be an issue. So what this does is it will slide over until it finds a digit, basically. So when there's a digit entered and this moves forward, there's a piece that sticks out the front, and that will catch on this cam here, the same metal piece in the front, and stop the whole assembly from moving. And then once it does that, as far as I can tell, it'll start the countdown. So there's another piece down here. I'm not sure if you can see that little tab. It's kind of like a ratchet thing. So that will slide past. Basically, this register does the same thing. These things will move forwards or backwards depending on whether there's a digit entered in there. So there's another piece on here that slides with the register. So this register will slide out until it's stopped by a pin sticking out the front of the front register, stopped there, and then it's spring-loaded back, and it'll spring back until this tab is stopped by a piece sticking out of this register. So this whole thing moves forward and then springs back until it's stopped by the leftmost position, which is rightmost because we're upside down now, but in normal operation it would be the leftmost position, the highest digit in this counter register here. And then once it stops there, it'll go into add mode, so I believe it will read the value from this frontmost register, add that in, and at the same time, this thing is counting backwards in that position in the counter register. And then when that column gets to 0, this piece will spring back, pulling the tab out of the front, which will release the ratchet, and this thing jumps over to the next position. I can see if I can kind of show that. It's going to be really hard to see because it's all the way down in the bottom here. But basically that's kind of the gist of how the multiplication mechanism works on here. And then of course there's going to be some kind of trip when it gets to the end position, which I'm not really sure what that is, but yeah. So basically what the issue with this was this counter register was entirely frozen up. This sliding assembly was entirely frozen up, so it wasn't sliding at all. I think there's still some stickiness in this register. Also, everything was, kind of completely out of time. So I kind of had to figure out how this was supposed to work and then kind of reset all these the wheels on this register so that it would slide properly because they were all kind of messed up. So basically the main issue is just sticky grease on all the parts. So had to kind of just clean up what I could, and it seems to be mostly functional. I think the issue with the printing zeros is probably some sticky parts, maybe over here in this timing section, because all these levers here I believe they run off cams back here. I think there's also some interaction with some cams on this camshaft too. So yeah, but like I said, the main issue was sticky grease and then just getting everything set up properly, properly in time and all, to get it to work. So definitely happy that that's working now. It's kind of a fight with that, had to disassemble all this, but yeah, so probably the next thing is playing around with the symbol and getting it to not print those random zeros. Not sure what's causing that. And then we move on to division, which is going to be real fun because right now the machine won't even go into division mode. Something is really locking it out. So yeah, anyway, pretty excited that I got multiplication working, so on to the next thing. I might go talking about with this can here. So this is the kind of the ratchet type thing I'm talking about, where the finger pushes on these flaps to rotate it. And you can see there's one here, and you can see kind of how tall that one is. You know, maybe just a little bit thicker than the end of my pick here. Then if you look at this one, you can see this one is closer on that. This one is a little bit taller, so I'm thinking that this is what I'm thinking. So this short one up here is one that the both of those pins that I showed earlier have to be, disengaged to allow the finger to drop down to hit it, because when those pins are engaged like they normally would be, it holds the lever up and it misses this piece here. But I think this one's tall enough, and maybe this one down here too, so that whether or not those pins are engaged, it'll always hit this and advance the timing. Like I said, there's also something I need to figure out. I don't really need to, but it'd be kind of nice to figure out what causes it to advance at the end of the multiplication step, because as far as I can tell, none of those levers are connected to anything else that would cause it to advance. When it gets to the end of multiplication, it has to get out of multiplication mode and allow you to change back to regular adding mode. So I'm still not sure what causes the can to advance at that stage, but so I think that's always wrong about it needing something else on the keyboard to advance that. Alright, so back upside down again, you can now see that I have both of these registers out of here, because I need to clean up the back one. You can see this is, over here is the set out of it, and you can see how bad this was. So you can see the dry grease in the back of the gear, and then the gear is face against this side on one side. So that's all caked in dried grease, and then this side on the other side. And it was really hard to get the shaft out of there. These pieces were really frozen on the shaft, and the shaft didn't want to come out. So that was a bit of a fight to get that out. But here's the register assembly, and this is the D10 portion. So you can see that it rocks back and forth, and this wedge here goes into the gear teeth to lock them in place. And then these are those fingers that stick out the back that hit against the peg, which I can show you now, that the register will slide until one of these fingers stops against that peg. And then they have little tabs on this side that are caught by the little extra tabs that stick out of the gear there. So those little tabs that stick out will hit on these to indicate a zero position. So over here, you can see this is the shaft here that the register attaches onto, and then this whole shaft slides back and forth to slide the register. And let's see if we can get down in there a little bit. I think you can see this piece right here is that little tab that sticks out, and that's what catches on those hooks on the back of the register, those tabs in the back of the register. The register slides over until something stops against this, and then it springs back until one of the tabs on the counting register stops it, and then it'll start multiplying and counting from there. So I just need to get all this cleaned up. I already cleaned up this housing here. I'm just going to put some oil on the detent pieces. Let's get that on there real quick. I'll put some oil on those. Just ran some oil on the back there. Maybe a little bit more on the front. It's kind of hard to do this in front of the camera because I've got the camera set up right now. Just going to do this real quick off camera here. And then we should be able to come back up in here. So it's got two little hooks in the top pieces that go, oops, this has to come forward. This has to come forward against swing tension, and then that hooks up on there, and then the shaft goes in like that. So now that's ready. You can see it's gonna, well, just knocked it off, but it would slide. Maybe. Well, it's not gonna slide now, right, because all of these are sprung back because there's no gears to hold them forward, so that's why it's not gonna slide. So all those fingers are sprung out the back, stop against that tab that I just showed earlier. Because there's no gears in here, so there's no extra teeth to pull these forward. So I'll have to wait till we get all the gears back in, and then you can rotate them till all of the fingers are forward, and then I should be able to slide free. But got to do a bit of cleaning first for that. But basically then, this is one I've already cleaned up. You can see it's much better. So you can put these in one at a time. I haven't cleaned up any gears yet, but then the gear will go on. This will not stay up there, but I'll put the gear on and then keep working across. And the last one's going to be fun to get in because you kind of have to like wedge it in. But yeah, so let me finish cleaning up all that stuff, put this together, and then we can put the register back in the front because you have to take that one out to get this one out. It's not very convenient, especially to get this piece out. So this is the finger that slides with the assembly, and this is what stops on the back of the tabs on the counter register. So that is basically, see, it's gonna be kind of hard to show, but actually this belongs over here. But this would be basically right in, yeah, I have to put it in the side first. Right in kind of around there. I didn't put this side in because I kind of have to push it over and then get it in. It's not very easy to get in and out. Kind of have to bend these over here a little bit to get it in there, but that sits right around in there, and then the finger, you can see sticking out here. So the whole assembly slides across until one of the tabs on the back of this register hits the finger on the back, and then it'll spring back until this tab hits one of the fingers on the back of the counter register. So, and it'll start from there. So hopefully that makes sense. Get this cleaned up, put it back together, and see what it does. Alright, so I think I got that reassembled correctly. So I don't have any extra parts anyway. So like as before, it slides nice and freely. So let's flip this back over and see what it does now. Let's make sure that regular adding still works, which it should. Well, keyboard's sticky for some reason. That's interesting. I'm sure it's sticking there. Keyboard was sticking a little bit, but now it's the other thing. Still got the sticky totals. Still got the sticky totals sometimes, or it doesn't always print out the totals. So I'll look into that. Let's go to multiplication mode now and try this. Let's do 25 times 25 something. Still putting on all these zeros. Let's go back to that. And it did a bunch of garbage. Not quite sure what happened there. Okay, let's try it again. 25. 25. So putting out a bunch of zeros. Okay, so 675, so I added an extra one for some reason. So still not completely fixed yet. I think what's supposed to happen is after it's done, it's supposed to print out the result, not print all these zeros. So you have to keep going back into regular add mode to print out the result. So there's still something wrong with that. Try it one more time just for fun. So we're still doing, actually it did 2 extra, right? It should be 625 and it added an extra 50. So that's interesting. What if we just do, this is clear, what if we just do 5 times, oh, did 4. Yeah, so now it's doing an extra one, so something is still not right there. It should be 16, but it put it out 20, so it added an extra thing. So gotta figure out what's going on with that. It's funny, it was working before, so I don't think I got anything back together wrong, but maybe there's some other new issues. So yeah, I'll have to figure that out, but this machine is definitely not going to come out together easily, and like I said before, I don't think it'll go into division mode, so I'm trying to push this down, yeah. Completely blocks on trying to enter division mode, so that's another whole issue, but I'm going to focus on trying to get multiplication working completely before diving into that, and I still have to figure out subtraction. If you enter something like 25, and then try to subtract 6, which only entered 4, so there's still something sticky there. The total. Now it's stuck in non-total mode for some reason. Yeah. So it basically just added instead of subtracted. So, and it still got these sticky totals. So still got some stuff to figure out here. So it looks like so far rebuilding that register didn't actually have any effect, but it definitely needed to be done because everything there was pretty sticky, and maybe that issue would have shown up in division if we ever get there, but yeah, definitely a lot of issues with this machine, so I'm going to keep working on it and see what we can get. Alright, so I think I may have got subtraction working. So if you can see, but I entered 1, 2, 3, and then subtract 9. It didn't print minus for some reason. I'll have to look into that, I guess. But anyway, you can see that it did actually subtract. So 1, 2, 3 minus 9 is 1, 1, 4, and the carry worked there. I did enter a 0 to help reset the carriage, so I don't know what's causing that. But let's try it again. So I do have the keyboard out, but you can still enter manually. So I'll enter a 0 in all these columns here. And let's try something like 25. So 1, 2, 3, 1, 2, 1, 2, 3, 4, 5. That should be 25. Yes. And if we want to subtract 9, give us 16. There's 0 in all those columns, and then nothing in the last column. I subtract. I'm going to all zeros just to help the carries reset. And now let's change this to subtotal just in case there's an issue. So if I hold this over, it thinks that should allow me to subtotal, and we got 16. So yes, subtraction does now work with the exception of it printing a minus sign. I don't think this is supposed to have a dual color ribbon because the ribbon's not wide enough for it to have a dual color, and I don't think there's anything to shift it either. Looks like it's part of the frame, the ribbon support. I was looking at the ribbon support here. I don't know if there's anything that can move that. It seems to be part of the frame. So I think it's supposed to put a subtraction symbol, but it's not. So it's another issue yet. We'll clear this out. But progress anyway. So the issue, what was the issue with that? The issue was down here. So we're going to be able to see right there, I think. Yeah, so see that little peg right there resting against that little lever. So when you push the subtraction key down, that peg drops, allowing the lever to spring forward. And what that does is it engages down in here. You can't really see it, but there's a lever that is either held into or out of position with a peg on the main shaft that reciprocates all the way across. And when that lever springs forward, it allows that lever to engage with that cam, and it rotates this shaft right here, right down in there, that kind of dirty gray looking one right there. And when that rotates, I'm not sure if I'll be able to demonstrate. Let me unplug it just to be safe. See if we can manually actuate that. Yeah, so I'm not sure if you're going to be able to see, but what happens is this lever here will spring up. So see how that springs up? Better view straight on. So see that right there springing up? That adjusts the register location. So I think I was wrong before when I said that there were two registers in the back. There's not. They're combined as one. There's no way to decouple them from each other. But what they do is one set of gears acts as a reversing set for the other gear. So like one set of gears acts as the main register, and the other set of gears acts as the reversing set. So to add, you can engage with just the main register. But to subtract, you engage with the reversing set, and then the machine basically operates the same way it does for addition, but because it's got that reversing set of gears in there, it turns the register backwards for subtraction. So that's why there's two sets of gears all the way down. Better if I show it, probably, all the way down here. So one set here, guess I have to put it back together. One set here and one set here. One of them is the register and one of them is the reversing assembly. So what that does is that prevents that starting assembly from being pulled forward to engage with the register, and instead allows it to remain back with the reversing set engaged. So that's what that does by lifting that up. It lifts this up to not engage with a cam that will pull the main register into engagement, and instead allows the reversing set to engage. So that seems to work. Like I said, still missing the minus key, but I think what I'm going to do for now is put this machine aside. We've made a decent amount of progress on this. Multiplication almost works, which is better than nothing, which is what I was doing before. Subtraction works, addition works, totaling and subtotaling works. There's still something up with the credit balance mechanism. So this machine is a credit balance machine, which means that if you get a negative number in the main register, it'll, instead of printing the complement, it'll actually print out the negative result with a credit symbol. So you can see I got into that mode here. It's printing all nines with a credit because whatever detects whether it's positive or negative seems to be messed up, and once it got into negative mode, then it got stuck there, and so it was printing the complements of positive numbers instead of printing the positive numbers themselves like it's supposed to. So that's still an issue, and once it gets into credit balance mode, then it can't get back out, it seems. But that's how that works. So basically what I was adding here, and so that should have been like, sum of 2, but because it was stuck in credit balance mode, it was putting out the complement of that sum. You can see the little C there for credit. So that's still messed up. Division, no idea about that. So the reason why this won't go into division mode is because this little piece here is hitting against this peg here, and that prevents it from going into division mode. Now this doesn't seem to move. I tried tapping on it, I tried twisting it. It really seems like it's a solid part of the case. So whether this machine was sold as a cheaper option with division disabled, or what's going on, I really have no idea. So still a mystery on division, but I won't even go into division mode, so I really don't know about that. But like I said, I'm going to put this aside for now. Spent a lot of time fighting with this machine, and the way it's designed, it's not designed to come apart very easily. Like the assemblies that I've taken apart involved quite a bit of fighting to get them apart, so kind of getting a little bit annoyed with the design of this thing. But anyway, like I said, we did make a decent amount of progress on this, and a good amount of the functionality is either fully working or very close to fully working, with the exception of division, because I have no idea why I won't even go into that mode. So anyway, like I said, I'm going to put this aside for now. Maybe we'll pick this back up again at some point in the future, but I hope that at least this was informative as to how the multiplication mechanism works and some of the other functionality that we fixed. So hope you enjoyed this video, and thank you for watching.